Hello everyone, welcome back. So in this video we are going to understand this problem maximum side length of a square, or we can say it's very important to understand how we will use the prefix sum and the binary search over this problem, right? So this problem, basically we have to find the maximum side of a square. This is the problem we have here, and how we are going to use, right, here the prefix sum and binary search that we will see in this problem, right? Very first, this problem looks easy, but the most people fail it in the interview, because today I'll try to break this problem into very simple steps. So let's try to understand and think that if the prefix sum of binary search on the answer it will confuse you, then how we will fix this type of problem, you can say that. Understand? So what you have given, very first we have given is a 2D array we have given, as you can see here, right? So 2D array is nothing but, it is called a matrix, right? And these numbers are we have given is a positive integers, as you can see here, right? We have given. So a number called threshold, we have also saying that we have to find the maximum side length of a square with some less than or equal to threshold, right? So and there is a number also given in this example. First we have given matrix, and another we have given is a threshold, we can say that. And what is our task? Our task is to return the maximum side length of a square, okay, such that the sum of all the elements inside the square, we can say, let's suppose for this case, right, should be less than or equal to the given threshold, right? So if you see here, it is getting how many? 2, means 2 is less than equal to 4. This is the condition it is saying should be. So the main thing is that you should understand what is given. The importance is here, it is talking about that you have to return the side, right, of the, let's suppose if this is a matrix, right, or sorry, or you can say submatrix, we can say. So you have to return the one side, not the area, that we have seen in the couple of videos in the last 2 days, I guess, right, where we used to send the return the area, but we have to return the side, one of the side. What is the maximum side that we will create in the submatrix? That one side you have to return. That is why we are getting 2, right? So there is one more thing that you should understand is what is this? So basically I want to make a clarification that if this type of question saying that, right, and you have given matrix and you want to find the square, right, it means what? The square must be contiguous. Contiguous, understand, right? Means after it's like 3 elements we have like this, right? So you cannot skip any element in this, okay? It should be combination of 3, or it combination of 2, it combination of this one, right? Like that you have to take the contiguous element, means you can't skip one cell. Let's suppose you want to skip this cell, you want to skip this cell. No, you cannot do that. You can't skip cell, right? So the bigger square means more number. If you are getting many elements, right, it means the square gives you the more numbers, right, which means bigger sum. If it gives you the bigger sum, right? So the real challenge is how do we check square sum efficiently, right? That we should understand how we are going to find it here. Understand? So let's go through the example first that we have given. Very first, as you can see here, we have given 1 we have given, right, in the, then we have 3, 2, 4, 3 and 2, and all are 3 times in the row, means row 1, row 2, row 3, right, that we have given here. So if you say here, right, how many columns are there, we'll say 1 2 3 4 5 6 7, and how many rows is there? 1 2 and 3, means 3 rows we have given and 7 columns we have given here. Okay, the very first threshold what we have given is 4 we have given. Okay, so let's try the different square sizes, we can say that, right? What are the possible size? Very first, when we'll take size of, let's call 1, right? Then how many cells we required? So any cells, let's suppose call 1, right? We will take, or 2 we can take, right? 1 or 2, let's suppose we can take also 2, right? Either you will take 1 or 2, right? It means the square cell number of cell in the square is 1 or 2, right? Which is less than equal to what? 4. 4 is what? Your threshold, right? So it is valid. Okay, now think about, you are going to take the size of 2 in the square. So these are, I'm talking about what are the possible square are there, right? Means we want to try different sides of the square, right? So if you want to create a size of square size is 2, right? It means how many cells you require? Means 1 1 and 1 1. Can we say that? So this is your square became, right? And in this case, either there is one square, one element, or you can say 1 and 1, right? That is gives you 2. So if we are taking 1 1 1 1, right, means 4 cells we have given here of size 2, means 2 cross 2 is gives you how many? 4. So you are getting all the values here is what sum here you are getting is 4, right? All cells plus, right? So when you are taking size 2, means 2 cross 2 is how many elements is there? 4 element. If you will do the sum, you will get 4. So this is also valid square, right? Let's talk about if we have more than 2. So as you are going to take the, let's me write here, if you are going to write the size of 3 of a what you call square, right? It means what? It should be 1 1 3 1 1 3 1 1 3. How many elements we have here? Total 9 elements we have, right? If we'll do the sum, so 3 3 3 9, then you will start 3 and 3 is 9 12 and 3 15. Total you are getting is 15, right? So it's too large, it's exceeded the threshold, right? So this will not be qualified for our, and this is not basically it's too large and it exceeds the threshold, we can say that, right? So the maximum square side length is here is maximum is 2. Okay, and that is why you are getting the answer here is 2. So make sure that you understand the problem, right? So the brute force idea is very simple here, but if you try the every square as we are seeing here, so you have to calculate the sum of the cell by cell, you can say that, right? And that gives you, let's suppose it's a time complexity. So number of cell is, let's suppose, is becoming, and you are trying the brute force approach, obviously for all the cells, right? Because for all the 4 directions you need n to the power 4, right? So this will absolutely time out in the interview, right? And TLE exception you will get, right? Time limit exception. And basically you should not try the naive approach, that is the brute force approach. So you know that if you want to find the sum, right, and if you want to calculate the problem in that you will get the better time complexity, you know that you have to come out of the time limit exception, right? What you need to do, basically we should optimize this problem, right? And we know that there is a sum thing, right? And we have to find the sum, so we will use the 2D prefix sum and try the binary search on the answer, right? So basically we need to optimize by two optimization we need to do. on the calculation of the sum in O of 1 time. If you want to do the sum calculation, right, you need to do in O of n, O of 1. And you have another thing you need to do, what is to avoid the checking all the sum blindly. You will not find the sum like this, right? That you will say, okay, what is the sum, what is the sum, what is the sum, right? No, you don't need to do that, right? You just need to use the prefix sum, right? And then we use it. Means this leads to the prefix sum to the array and binary search on the answer that we will do, and we'll try to implement it. So how we are going to do the prefix sum, right? Let's suppose let me clear here. Okay, so let's suppose if you want to do the prefix sum, right? So prefix sum allow us to know the sum of every rectangle instantly. So what you need to do, you need to do prefix sum. How? Let's suppose if you have prefix like this and I and j, right? So if you want to find the prefix sum on the array, what you need to do, you have to take the sum of elements, right? So sum of elements from 0 0 to I minus 1 and j minus 1. Understand? If there is a matrix and there is a 4 cell is there, if this is 0 0, so you know that I plus 1, I minus 1, j and j will be continuously there. I will be same, j minus 1 and I minus 1, j minus 1. So from 0 0 to this you will get, right? So this is the sum. So never forget this thing, how we will use the prefix sum on the 2D array and how we will find the prefix sum. Understand? Basically you have to traverse over the all the 4 cells, and that is why you have to start from the 0 0 to I minus 1, j minus 1. Understand? This is your ij. If this is your ij, you know that what is the value of this and this and this, right? Basically you are trying to go from 0 0 to the last cells. Okay, now you will say what is the sum value, right? So you understand. Let's suppose you want to find the square sum formula, right? How you are going to find this sum, right? Let's call this sum, and here you know already have calculated the prefix sum. If you prefix sum having row and column, right, definitely you have, you just need to do what? Minus. Let's call minus here. So basically you need the prefix sum and row minus size and column. Means if this is I and j, the very first is all the 4 direction you have to do, right? Means row and column minus r minus size, then again you have to do what? Minus prefix sum, then you need here is r, and here you will need your c minus size, right? Then there will be a plus, then you will use the prefix, and here you need to pass what? Row minus size and c minus size. Can we say that? So we have to take all those 4 cells value and you have to find the sum. So this gives you the sum in O of 1 time, we can say, basically O of 1 basically, right? O of 1, and we'll use this formula to find the sum. Basically we want to slide over the square. Let me tell you how. Let me tell you that if you remember, if you want to find, let's suppose we have given a matrix 1 2 3 4 5 6 7 8 9, right? If this is a matrix you have, right? So you have to convert this matrix. Let's suppose this is original matrix and you want to convert into the prefix sum. So how you are going to find the sum? So you say, okay, this is your prefix sum matrix. Can I say that? Very first cell we know that it will be 0 0 0 0, right? And because this is 0, so all cells also will be 0, correct? This is the prefix sum requirement, correct? If this is 1D array, very first element is 0 and rest of the element is we have to do the sum. So the one having the prefix is what? 0 here and 0 here. This is the meaning of the thing, right? Here we are considering the prefix value 0, like this we are thinking, right? Then it will be 1, then it will come what? 3, 1 plus 2 is 3, and 3 plus 3 is 6. Like that we have to find. Then it become 5, 1 plus 4 is 5, then it will become what? 6, and 5 is 11, and it's 12, then it will come 21, we know that, then 12, 27 and 45. Remember guys, so this is what we have to do, the prefix sum of if we have given the original matrix, and then we have to find the prefix sum, right? So if you want to find the, let's call the sliding window using the matrix on any of the array, right? Either, let's talk about if this is the array we have given. Very first we have to slide over the array like this. We will take this array first, we will calculate whatever we want to do on this one. Then the next array element will become what? We have to choose these two, and if there is more element, so we have to choose like this, and if there is more element like this we will keep going till the last element, right? So if we know that there is some root rule, it means if this is a timestamp, we'll start from 1, 2, 3, 4 until we'll go L-1 and L, right? It means if there is 2 element is there, 1, 1, 2, 2, then we have given is let's suppose we have given is 1, 1 and 2, 2, means you have calculated this element, then you have calculated this element. Okay, so this is a way we find the sliding window using the matrix. So you have to choose the matrix and you have to keep sliding till the down, from top to down, you can say that. Okay, and then you will find the sum. This is what we will do here guys. So the benefit over this is we know that we will use the prefix sum, right? And that will give you the O of m cross n. And if you want to do the binary search over any element, right? So for the binary search, we'll take log or log m, we can say, and what is the minimum between m and n, right? That is the binary search time complexity. Okay, so and if you want to check anything, it will give O of m cross n guys, right? Means overall, if you say the time complexity, give me 1 second. So what we will become? So it will say O of m cross n, then log we will take, and the minimum of m and n. So this is the time complexity that you will get overall here. Let me show you the code, how I have written the code. Okay, so the very first thing is that, give me 1 second. So as you can see, you will build the prefix sum, and you will write int prefix int new m plus 1 n plus 1, and then you will find the prefix like this. Then you will do for the binary search, you will write left and right and keep finding the mid. If you are able to find the this exists the square or not with this, then you will increase the left at mid, and right you will reduce to m minus n. If it is not, then you will return the left. How will find the existing square or not? So you will find the prefix sum in size threshold, and for all the combination I and j, you have to find the sum. If the sum is less than equal to threshold, it's true, otherwise return false. This is what we need to do guys. So I'll put this code in the comment box. You use this code, do the debugging, and that's all I have in this video. Thank you for watching this video. I'll see you in the next one. Bye bye.